NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
For over 50 years, Voyager 1 has been humanity's eyes in the stars, sending back groundbreaking data from the edge of our solar system. But now, it's sent a signal so strange that it defies everything we thought we knew about space. Over 15 billion miles from Earth, this tiny spacecraft has encountered something baffling, something that could change everything. Could it be a new cosmic discovery? Or perhaps a sign that we are not alone? Join us as we dive into the mystery of Voyager 1's latest and most mind-blowing discovery yet: the unexpected message from Voyager 1. Some 15 billion miles away from Earth, Voyager 1 is still an active guardian in the vast silence of interstellar space. Sent in 1977, its ongoing transmission is a tribute to human engineering, transcending projections as its nuclear fuel gradually drains. Engineers had long anticipated its eventual silence. But then, a flash of data, unexpected and deeply anomalous, arrived, leaving the scientists both stunned and deeply alarmed. This was not a normal transmission. Voyager 1's older equipment picked up an extreme and unpredictable burst of cosmic radiation, unlike any other data that has been gathered since it passed through the heliopause in 2012. The heliopause, previously considered a comparatively tranquil boundary region, now seems much more unstable. The radiation levels were not only greater, they showed sudden erratic spikes and had nothing in common with cosmic rays from supernovae or gamma-ray bursts. No source or astrophysical phenomenon known to science could explain the magnitude and character of the readings. Additionally, the radiation did not have the standard energy signatures that researchers use to determine cosmic origin. It was not thermal or electromagnetic in any conventional manner. This has prompted theorists to speculate that Voyager 1 crossed into a previously unmapped area of space controlled by unfamiliar physical forces. Some have even postulated exotic matter or dark energy concentrations that could not be detected before. Most importantly, the patterns of data indicated rhythmic pulses, regular cycles of bursts of radiation that suggest a structure or source below. No one is suggesting intentional communication, but the patterned character of the anomalies is something that is not naturally seen. Added to simultaneous irregularities in the local magnetic field, this indicates a highly complex dynamic setting. NASA officially classifies the observations as anomalous deep space activity, a tag reserved for what doesn't fit into today's scientific paradigm. Voyager 1's instruments, although old, are still calibrated and functional, so equipment malfunction is an implausible cause. The spacecraft possibly is nudging against the edge of a structure of galactic proportions, or maybe it's having an encounter with a remnant of an ultra-distant, long-ago cosmic occurrence still emitting across the ages and throughout space. And so the signals keep coming, while scientists worldwide race to crack their codes, looking at patterns compared with established astrophysical datasets and models. The consequences are not fully clear, yet this much is true. Voyager 1 has opened a new page in humanity's exploration of the universe, solving boundaries in current physics and potentially resetting humanity's status in the cosmos. The disturbance in the magnetic field. Perhaps even more perplexing than the recent increase in cosmic radiation are the magnetic field anomalies that Voyager 1 has started to measure. In principle, the interstellar magnetic fields beyond the heliopause should be fairly uniform, molded by a balance between the declining influence of the solar wind and the constant galactic magnetic currents. Models for decades predicted this region to be tranquil, a huge ocean of uniform fields with only subtle, slow change over long distances. What Voyager 1 has observed refutes these long-standing hypotheses. The spacecraft's magnetometer is sensing extreme and chaotic distortions in the field around it. Swift directional changes, huge spikes in magnetic field, and wild, unpatterned fluctuations that just keep going. These events are not temporary. They seem to be a continuing and possibly accelerating phenomenon, something entirely different from anything the spacecraft saw within the solar system. The magnitude of disruption implies something underlying at work, a force that reaches far beyond Voyager's local environment. One explanation gaining acceptance is that Voyager 1 might have entered a transition region between interstellar realms, a boundary layer between slow-moving, enormous clouds of interstellar plasma. These boundaries, also known as interstellar current sheets, might harbor magnetic shear zones where field lines become tangled and reconnect. Such interactions can release immense energy and upset local magnetic stability. Others in the scientific community have explored the notion that Voyager 1 has passed into the Objects such as unbound planets or old neutron stars can exert gravitational or electromagnetic influence that ripple space, distorting the surrounding medium subtly. Especially persuasive is the idea that the distortions could come from a nearby primordial black hole, an old relic of the early universe, tiny in size but incredibly massive in gravity. Its presence could quietly curve both space-time and the magnetic fields in its vicinity, creating the type of anomalies now seen. Even more speculative is the possibility that the spacecraft is encountering remnants of non-natural origin, structures or debris of unknown design, affecting the field in ways yet unknown. Though this approaches the edge of present scientific consensus, the data cannot be explained by any known astrophysical effect. The lack of optical instruments aboard makes verification all but impossible, so deduction must be based only on sensor readings, magnetometers, plasma wave detectors, and particle counters. Engineers and astrophysicists are presently studying the data with international observatories and theoretical physicists. Highly complex computer models are being processed in trying to replicate the field disturbances and model potential causes. The hope is to determine if Voyager 1 is simply traversing a naturally turbulent area of space, or if it is skimming over something much less common, something that suggests a much greater, more intricate structure within the cosmic fabric. Regardless of the origin, the magnetic disturbances mark a profound and unexpected chapter in Voyager 1's mission. They force a reconsideration of what lies beyond our solar bubble and challenge the long-held belief that interstellar space is uniform and passive. Instead, Voyager 1 is revealing a turbulent frontier, rich in phenomena that may reshape our understanding of the galaxy's structure. Time is running out, but the information just keeps on flowing, and each transmission might contain the solution to solving one of the most profound enigmas of the deep universe: the mysterious cosmic rays. As if the previously recorded radiation and magnetic field anomalies weren't concerning enough, Voyager 1 has now sent data that shows a mysterious and record-breaking increase in cosmic rays, high-energy particles that normally emanate from distant supernovae, pulsars, and other violent cosmic activity. Normally, these rays become more common the farther away a spacecraft gets from the sun's shielding influence. But what Voyager 1 saw was not a uniform increase that any astrophysical model could predict, but a wild and sudden spike that contradicted all known astrophysical models. In contrast with the expected uniform buildup, this sudden burst seemed to come without any known cause. Even more anomalous, the levels did not settle at a new baseline. Instead, they started oscillating in complex, almost rhythmic motion, building up and falling over hours, then changing suddenly over days. These fluctuations are unlike the natural background cosmic ray randomness. Rather, they suggest some possible structure or modulation of the particle flow and imply that perhaps the source of this radiation is not all natural. Voyager 1's elderly but tough particle detectors verified that these fluctuations are not one-time phenomena. The data has been corroborated by redundant instruments on multiple spacecraft. The energies of the particles are unusually high, but the distinguishing factor is their seeming organization. Cosmic rays are typically deflected by interstellar magnetic fields, hitting in a disordered, diffuse beam. Voyager's instruments have detected concentrated bursts and recurring spikes, signatures indicative of a centralized or directional source. One speculation that is in the spotlight is that Voyager 1 is crossing through a remnant stream of particles from some long-forgotten hyper-energetic astrophysical phenomenon, maybe the shock wave from an old, long-extinct quasar or hypernova. Another theory postulates interaction with a dense interstellar filament or some as-yet unknown galaxy structure that focuses particle energy into coherent streams. Both concepts would necessitate modifications to well-established models of the interstellar medium. Yet others indicate an even more remarkable possibility. The sophistication of the ray fluctuations may be a sign of artificial interference, signals within the radiation itself. Patterns, if verified, may be encoded information on high-energy particles, just as radio signals convey messages on our planet. Though not yet verified, the consistency and recurrence over several transmissions have led experts in deep space communications to analyze the data for structured anomalies. This finding raises severe challenges for the future of manned deep space missions. Long-used radiation shielding, once considered sufficient, may be useless in the face of such intense and variable exposure. Engineers now consider whether adaptive protection systems, radiation forecasting, and onboard alert mechanisms that might sense and react to similar radiation waves in real time are necessary. The cosmic rays Voyager 1 is now experiencing could be the echoes of a primordial cosmic turmoil, or they could be an unseen energy frontier. Either one would be of monumental consequence. These rays, once believed to be the universe's background noise, could now be its most mysterious voice, whispering secrets from beyond the void. What comes next for Voyager 1? Voyager 1, as much a child of 1970s engineering as it will ever be, is still one of the most incredible achievements of humanity. Launched in September of 1977, the ship was only intended to last a few years. But with its plutonium-powered RTG radioisotope thermoelectric generator behind it, it has kept going for more than 4 decades, traveling farther away from Earth than any other man-made object. It now sits more than 15 billion miles from us, in the enormous, unmapped sea of interstellar space. Its ongoing function is nothing short of miraculous. But its power supply, attenuated by time, is slowly eroding. NASA has already started shutting down Voyager 1's non-essential systems in a deliberate attempt to prolong its lifespan. The spacecraft now runs on minimal instruments, selectively broadcasting data considered most important. Every byte of data it transmits provides a glimpse into the unknown. Every year, scientists have to make harder and harder choices about which systems to continue operating, keeping essential sensors alive while saving enough power for communication. The goal is to stretch its mission to 2030, an incredible 53 years from launch. When Voyager 1 eventually falls silent, it will continue its immortal journey through the galaxy as a quiet ambassador from Earth. Powerless and speechless, it will be a floating monument to human curiosity and ambition. It bears the now famous Golden Record, a message of music, greetings, scientific illustrations, and the variety of life on Earth encoded on a golden disc. This document, attached to its body in a protective case, is meant to endure for 1 billion years. Whether or not it is ever found, it is a gesture of hope, a message in a bottle tossed into the cosmic ocean. Until that day of silence comes, Voyager 1 continues to be an ongoing source of scientific knowledge. The anomalies it has just discovered, increasing cosmic radiation, bent magnetic fields, and unpredictable cosmic rays, are remapping our understanding of what exists beyond the heliosphere. These observations have uncovered a dynamic and turbulent place, far removed from the serene emptiness previously anticipated. Voyager 1's readings are important, not only for scholarly comprehension, but for planning future missions. If humans ever do venture out into interstellar space, the data Voyager 1 is giving us today could be the basis on which it all occurs. Additionally, the continued operation of Voyager 1 is a lasting testament to genius. Crafted with technology older than modern computers, it continues to send messages back to Earth through a 20-watt transmitter, roughly equivalent to the wattage of a refrigerator light bulb. The deep space network has to point enormous antennas precisely in order to receive its weak whisper. That we can hear it at all is a victory of engineering and human determination. In its latter years, Voyager 1 still inspires. Its mission is no longer solely one of scientific exploration. It's one of legacy. Years from now, long after the lights on board have faded and the signal has ceased, its influence will remain. Voyager 1 will take humanity's tale among the stars, an eternal traveler that silently bears witness to the universe. The final revelation. Weeks following the first reports of anomalies, Voyager 1 sent a brief but clear signal that did not correspond to any recognized cosmic phenomenon. This time, it was not mere noise or radiation. It was a coherent pulse, repeating at regular periods. Scientists first suspected it to be a transmission glitch, but after cross-verifying and re-authenticating, they attributed its source, interstellar space. And this pulse was not from Voyager 1. It was arriving for it. The notion that there is something out there, answering or reaching out to Voyager, has captured the imagination of the scientific community. The encoded signal is not of nature. It displays signs of intention, rhythm, frequency, and intervals too specific to be random. Linguists, mathematicians, and physicists have united to decipher its meaning. Is it a greeting? A threat? Or perhaps just a probe sweeping the universe for intelligent life, as we sent Voyager out to find? NASA hasn't made available complete information on the signal, fueling speculations from alien contact to interdimensional activity. A whistleblower even alleged that the signal looked like Fibonacci sequences and encoded primes, patterns employed in theoretical extraterrestrial communication. If that's the case, everything changes. It would mean not only are we not alone, but we've been seen. A legacy that will endure. Voyager 1's journey is more than a scientific mission. It's humanity's search for meaning in the universe. As it goes farther than anything else, its dying signals convey more than information. They convey significance. Outside the solar system, it has encountered weird energies, twisted magnetic fields, and cosmic rays that defy predictability. Every transmission tests our understanding, one that describes a universe far more intricate and pulsating than we thought. What started as an engineering achievement has become a reflection of our pursuit of knowledge. Voyager 1 is now more than a spacecraft. It's a guardian at the outskirts of life, revealing discrepancies that challenge the pillars of contemporary science. Whether these revelations are leading towards unfamiliar astrophysical mechanisms or even life itself, one thing is certain. We are experiencing something remarkable. Voyager 1's mission is not discovery alone. It's about keeping humanity's spirit alive. Inside it lies the golden record, humanity's gift to the stars. Long after it goes dark, it will keep traveling, taking the voices and sounds of Earth into the great beyond. Its last signals might one day be regarded as the defining moment in how we comprehend the universe. The legacy of Voyager 1 will remind future generations that exploration is not only about going somewhere, but about broadening what we can imagine. Comment us your thoughts, and thanks for watching.